Right, we are recording. So we're going to go through the Rocketsplit project, and specifically what we're going to do is we're going to look at a feature that we discovered recently that required us to keep track of RPL that was on an existing withdraw address whenever a user is migrating to a Rocketsplit address.
Yeah,
Right.
so that could be a validator that's just a regular validator, or a validator that's already integrated into a Rocketsplit. So just kind of like an upgrade of a Rocketsplit.
Yes. Yeah. Exactly. Cool. So we were going back and forth with Ramana on this, and we went through a couple different ideas, right? And I think we landed on this idea. And let me go ahead and so this is the actual smart contract, right? This is the Viper code that powers a Rocketsplit withdrawal address. And if we look at the if we look at the deploy, so what we do here with the deploy method, it takes a couple of different parameters here. We have the node address, so this is the node that's going to be using this Rocketsplit address. Then we have the ETH owner, who's the owner of the ETH, the RPL owner, the owner of the RPL, and then we have this data structure called fee that stores the different fees that both the ETH owner and the RPL owner can charge each other. So the ETH fee would be in RPL, and the RPL fee would be in ETH. These are all implemented. We've been iterating on this for some time now. Those are working. The new piece that we're looking at today is this Boolean value RPL refund. And this RPL refund, basically, it's just a Boolean, so it's true or false. And if we set it to true, then let's just dip into this and just read this real quick to see what exactly it's doing. So it's calling setup, it's passing that to setup. Then we're going to setup, and we're saying, hey, if the RPL refund is true, then we're going to set the RPL refundee to the current node's withdrawal address. So it's going to say, hey, the RPL that's on the node now is owned by the previous owner of that withdrawal address. So don't use that RPL in this marriage because that RPL is owned by somebody else.
And just to follow that through, when that validator does a full withdrawal exit, it will set aside all of this to go to that designated old node address, right? So that could be your old Rocketsplit, and this will send things to your old Rocketsplit even though you've upgraded. So the front end will capture it and give you that available fee to collect. But it's that old setup.
Right. Exactly. It'll actually be in the smart contract though, right? So when with this all the front end's doing is passing in that Boolean value. So we're gonna get to that. We're gonna say it's true or false. We'll display it as probably like a checkbox or something. But if that's true, we're gonna capture the address of the withdrawal address of the node, and then we're gonna capture the value of the RPL stake. And then when this exits, so when we do an actual withdraw at the end of the life of this validator, or of this node I should say, this RPL refundee address will get this value of RPL, which is the RPL refund value.
Cool.
Yeah, so the front end's not keeping track of any of that. It's just pass. I think that was one of the
But
iterations where
no,
we.
what the front end is keeping track of is the index of all the Rocketsplits you've ever been a part of. So, right, so that if value is going to an old Rocketsplit, that old Rocketsplit isn't your end user wallet, right? Like, because your Rocketsplit is going to point to your actual wallet, but the value is actually going to go to an old Rocketsplit. So you need to claim that old Rocketsplit in order to get it to your end state.
Yeah, that's a good point. So like this has we can like have this chaining structure going on. If you go from a traditional just withdrawal address, a regular withdrawal address to Rocketsplit, and you have a refund value, and then you move this one to another Rocketsplit, and you say,
Yep.
hey, the RPL on that old one, I'm marrying somebody else, right? I got divorced and I'm marrying somebody else. Now I have another RPL refund. When
And
you
these will probably be these edge cases, but I'm thinking more along the lines of, hey, I have an existing node, and for one reason or another, my RPL collateral is dipping below 10%. So I want to take on a marriage But obviously, all the RPL that's on there currently will always be mine. And whoever I'm joining for a marriage, that's from that point forward. So when we do the full withdrawal on the existing validator, make sure I get my original principal back, and then whatever agreement I have with my new marriagee from that point forward.
Yeah, it's going to be interesting. We got to figure out how to test that too. Because now, so when we do exit when we exit a node, everything is closed, and we call withdraw on this. So we're going to call, there's a couple of methods here for getting value out, right, which are really important because we need to be able to, what do we call it? We just call it withdraw RPL. So here's where this logic is. So we say withdraw RPL, and we say if the refund value is greater than 0, so we have a refund, then we say, hey, refund balance, we get the balance, and then we transfer that balance to the value that we've captured, the address that we captured from the withdraw address.
Yep.
Subtract that. Yeah, so we would have to call this. It would have to be like a chain call. If there's 3 marriages, it would have to keep calling this.
I'm worried we still have for that. And I think we can get into testing without this. This is an edge case, but that's going to need some development because you need to be able to look up all the old indexes. So everything that you said that you proposed the front end being able to do, I just don't know that it was built yet.
No, it's not. So like it's not. It's really not the front end either. It's the event that we emit. So because we're emitting an event here, create a new marriage right here. We're emitting the ETH owner and the RPL owner as index. So anybody that's in a marriage,
yeah,
we still have to build this piece. But anybody that's in a marriage, when you come to Rocketsplit, the XYZ, it's going to show you the list of marriages that you've been a part of. And you'll be able to call any of these methods on, even if it's not associated with a withdraw address for a node, you could still call it, and you're going to have to call it to get your RPL out.
Correct. But it is the front end. It's the event emitter is already coded. That's done. We just need the front end to recognize that it happened and then represent it.
We need to read the events that emit. So we are having a problem with that. And if we do post this video, I don't know if somebody knows how to do this, but I feel the local DevNet, when I'm running this, I'm not getting events back as I was expected to do. So we have to test that on the testnet to see, maybe I'm just doing something wrong, most likely, or for some reason the local DevNet is not indexing events or keeping logs as I would expect.
Let's get it implemented all the same, and then we'll go to our base use cases. We got to get this into testing. This is an edge case.
Yeah, this is definitely an edge case. So all right. So let's go ahead and let's try to implement this on the front end. So we want to be able to support this idea of basically just passing in this Boolean value on the front end. So I just cloned down the Rocketsplit smart contract to the newest version to have this. I haven't even built it yet. It's not compiled. I don't have the ABI or anything like that. So before I spin up anything, I'm going to go ahead and just compile this, just to make sure that we can actually compile it, and this will output all the artifacts like the ABI and stuff like that, so that we have it. And what I've been doing is I just copy the ABI into the front end, so the front end has a copy of the ABI. So now it compiled it successfully, and I'm going to go ahead and I'm going to go into the React UI directory, and in the source directory we have an ABI directory that contains all of our ABI stuff. So rocketsplit.json is actually the ABI for the smart contract. So I'm just going to go ahead and copy this in the build directory, which is where Ape puts it. And I'm just going to bring it right here, right in the front end, so we know we have it. So with that done, now we have the ABI that contains the Boolean value so that we can now develop against it. But we can't run this yet because we do need a couple of pieces of software running for us to be able to actually test this. We need a DevNet, so we want to run a local fork of mainnet on our local machine. So to do that, we're going to use a program called Anvil, and this is in the documentation for Rocketsplit 2, but we're forking off of one of our staking nodes, and we do set a custom derivation path for our keys, how they're generated, and we are declaring a specific chain ID for our local net. So I'm going to go ahead and do that. And this is just going to go ahead and spin up a local DevNet. This is super cool because now I have like a copy of mainnet on my machine, and I could just hack away on it. And I have all these different test accounts that have 10,000 ETH in them each. So it's just like God mode pretty much. You can just play around, which is kind of cool. So there's a couple of tabs that we want to open up here to do other things. So what I'm going to do is I'm going to go into Rocketsplit here. And now what we can do is I'm going to do the same here. That's probably all we need, really. So go ahead and do I have this? I already have this open in VS Code, right? Yeah. So the next step is we need to deploy the actual contracts to this local DevNet. We need to deploy the factory that's going to be able to just create these Rocketsplit addresses for us. So to do that, we're going to go ahead and just run a ape script here. I'll run it interactively, so it'll stay on the screen here. And this will go ahead and deploy it, and we have our deploy address. As long as this is the first contract that you deploy when you fork mainnet, this contract address will always be the same. And in the front end, there is an environment, a .env file that contains all your environmental variables for the project, and this is hard-coded in that, I believe. Let me just make sure that that's actually correct. So if we go into here and we go to .e, yeah, so this is right here, address on mainnet. So when we deploy this, and I'll have to now edit this out because I'm showing the alchemy key here, which is typically you put private information in here. You don't want to show the world. So that's that. But all right, so
what happened to our silence?
Yeah, I'll have to just edit that. It's all good. Or I'll just revoke that key. It doesn't really matter. It's a test key. It doesn't matter. But okay, so that's that. Now the next step is we need to deploy or register a node. So in order for us to even use all this stuff, and this is the challenging part of what we're going through now with how do we actually test this thoroughly, is integration test, not just unit testing and stuff like that, but really fully use it and test it, is we need a node, and we need to be able to set the withdrawal address of that node, and then we need to be able to run value through the node. So what we're going to do here is that we have a setup script in the UI directory, and this setup script basically just takes one of the test account private keys and uses one of the test accounts as a node and registers it. So I think I have the test account 2 here is doing it. So if we just run this with Node.js, we go ahead and register it, and you can see here that we're throwing out transactions to this DevNet that we have running. So now we have a registered node. Awesome. Now we can actually run the front end. So we're going to go into the React UI directory, and now this is just a React.js project. So we can go ahead and run, is it dev? Or no, I'm sorry, it's npm start. Now we could just use npm to run a local of the project, and now we're running. Awesome. So now what we want to do is first we want to connect our wallet, of course. We're going to go ahead and connect MetaMask, and want MetaMask. This is another step here that I'm not showing, but you need to connect MetaMask to your local DevNet. So I'm not going to go into how to do that, but you have to connect a custom network and connect it to your local host to be able to do this. So this is all testy. This is just a test account. This is one of the test Anvil users. I've already imported the keys. So I've set up connected to my local DevNet, and then I imported the private keys into MetaMask so I can actually use these accounts as just a wallet. Now I have test transactions there. I'm going to go ahead and clear my activity in MetaMask so that my nonce is reset, so that everything is set back to nothing. And let's go ahead and plug this address in here. And now if we find this node, it should find it, and it should see that it's not currently a Rocketsplit address. And we can see that the balance of ETH is there, and there's no RPL in in this wallet, which is good. Now here's our marriage creator interface. So the marriage creator interface is really where we can create this marriage. Now this is what we're going to want to extend in order to support the Boolean value to say, hey, should we consider an actual refund amount or not? So what we can do is, let's go into our React UI here. And the way that this project is organized, tried to break this up into components that hopefully made sense. The marriage creator is the full creator interface. So this piece is going to be responsible for pretty much this whole box here that you see that has the different ways to create a marriage contract. So if we open this up, this does call into this method here, which is the deploy method. So the deploy method, and we're using WAGMI for this project, which this is the first time we used WAGMI, and I think, well, maybe not. Maybe we did use WAGMI.
We used WAGMI in one of the NFT projects.
Yeah. But you know what? I don't feel like we definitely need to use it at this scale. It's kind of cool. We're using a lot of these prepare hooks that are pretty cool because you can we'll probably do a whole series on this on YouTube, no doubt about it. There's so much stuff that we've learned here that is really cool from a front end development perspective on how to manage the execution flow of interacting with just chains, which is cool. But here now we have an argument property within this object that we pass into the use prepare contract write hook. And you can see here that we actually did implement the first piece. The first piece we actually let the front end pass in an address. We don't want to do this. We're going to go ahead and pass in a value here, and we're going to call it RPL refund, and we're going to set that as a state variable in React. So we're going to use the use state. So we'll go ahead and say RPL refund, and then we're going to say set RPL refund, and we're going to default it to false. And now what we're going to do is at the bottom here, where we're going to put this? So advanced inputs, fee inputs. So let's just try to put it right here. We're going to say display a checkbox to see if our AI knows how to do this. I think it did, Greg. I think it did. Okay, so let's see. So now we have a little checkbox here, and that is setting the state of the state variable that we just said. I don't think this is what we want to say. Allow. This is probably
send existing RPL back to send RPL on this validator back to existing withdrawal address.
What's withdrawal address?
To the
Show this withdrawal address here.
To bracket withdrawal address, when we enter it.
Here, so we could do that. And it'll show that this is what it's going to go to. It's not pretty, but we can make it pretty. Take this out of this division here. This is in one of the boxes. We want it outside of that. Yeah. So let's see if it works first.
Can we also existing? Can we just give the value of RPL on the node?
Yeah, because we actually have the RPL value already. This has 0 value, but we have it in. I'm sure we're putting that in a state variable here someplace because we're displaying it. So where do we do that? Let's see. Oh, we're not passing it into this component though. We could do that, but I gotta pass.
Do the actual look again.
No, I don't have to do it again. But so the withdrawer display here has it. Yeah, we'll have to. Well, technically, we're showing it up here, so we have to pass it back up the components and back into this to do that. But we can eventually do that. We don't have to do that.
Let's just make note to do it because I think that's clear. you're sending exactly how much to this address.
Yeah.
Upon full withdrawal, we'll probably have to put in like a little I dot and let an overlay. Don't want to clutter.
Yeah, because we are calling out to. So what I have to do is, yeah, we could do it. I gotta write the state. I need to push the state up the React tree here, which, yeah, do this and refund input. Don't we have? I want to create like a little bit of a design system here with some of these classes. Too much. If I put the checkbox on the other end and just keep this on the other end.
No,
too much space.
I mean, for now it's fine.
Damn it. All right, cool. So now that should work because we are passing in the RPL refund value to the constructor of the refund. Yeah, okay. So now we implemented it. So now if we go here and I'm going to just make this the same address. This is why we need heavy testing on this. And I'm just going to go ahead and do this and say yes. Create the marriage. Confirm.
Yeah, but it doesn't have any RPL to actually test.
No, yeah, it doesn't.
But we're in a test environment. Don't we have an address that can send it some RPL?
Yeah, we can figure out how to do
But
that.
it wouldn't even, but it's not staked, so it doesn't matter. We'd actually have to stake it.
Exactly. Yeah, we'd have to stake it. We'd have to stake it. You're right. All right, I'm going to set this. Boom. Okay, so that worked. We were able to get the value there. I probably want to show on this that there is an RPL refund associated with this withdrawal address, but I don't know. See, so here's where I don't know if this needs to be in this display. So this display is really the operations around this withdrawal address. So we could do things like change the withdrawal address. We could withdraw ETH, withdraw rewards. I'm thinking that we need a display that shows you a list of marriages and like properties in that table, and like a table structure where it just shows you the list of marriages. But
yeah, current marriages, you polygamous bastard.
Yeah, who are you married to? Yeah. But I don't know. It's a little. The ideas are mixing.
We get too many.
Well, because we're talking about a node, right? We start with the idea of a node. So if we show you a list of marriages,
when we say node, we really mean validator.
No, we mean node. Rocket pool node. This is all. So the rocket pool node can have many validators, right?
Yeah, got it. And we put the node. Yeah, because that's the Rocketsplit language. Rocket pool language. We're Rocketsplit.
So okay, so that works though. So we got that in place. I mean, I guess we could do something like here. We'd have to put another read in here to grab that value. So if we do like fund and RPL refundee. So like we could do something like just read these values, right? So if we go here on this display and basically do something like this, it's going to be, and what was the other one? RPL refund. And I do this twice. I wonder if there's a better way to do this where I can read multiple properties using one call to this. But I'm going to read this. I'm going to read this. And then what we're going to do is we're going to set RPL refundee and then set RPL refund, and then we're going to make these state variables. So we're going to say that, and I'm going to say that. And then if we have those values, we'll display them. I'm going to put them out here just to see if we got them. So we can say if Rocketsplit and refundee RPL refund, just so we can see it. And okay, boom. So we have the value. There's no refund, so we're not going to see anything. But we're going to say this too, though, because we want to make sure that.
Why wouldn't it show a 0 even though there's no refund?
I don't think it's set as 0. I think it's.
Didn't we already execute a refund? We said there is one.
We
So it doesn't have that state though.
Well, we said when we said setup, we said yeah, we have a refund, but then this we grabbed the RPL stake. This did not seem like it returned 0, so it's has no value in it. Let me see if let's make sure of that. So if we go back here, and let's go to where we called that out. So what I have to do is, this is interesting. This is a new value in JavaScript for large numbers. So I'm going to go ahead and just add like this to it, and this should now show 0 RPL. There you go.
Nice.
Okay.
Cool.
Yeah. So we gotta obviously put like some text around that and like make it a little more like clearer that what the fuck that is, but.
Cool.
Yeah. All right. So we just implemented that piece.
So that should make it mostly functionally complete, and we have to get this into testing. So
the only other piece there is the ENS setting, which is kind of a,
well, ENS and now the recognition of existing rocket splits.
Yeah, I think the recognition of existing rocket splits is more important for sure. We got to read those events.
Well, the ENS, I would say it's not more important, but it's probably quicker to do. So
the ENS is definitely quicker. Well, I don't know. Like
ENS is annoying, isn't it?
Yeah, well, that's another thing that really doesn't work too well on these forked local dev nets, and I really would love to learn why. I can't use ENS locally. It's not working for some reason.
Because doesn't it use it uses an external registry that doesn't exist in your local environment?
Yeah, but isn't it all on chain? Like all those contracts are on chain.
Recreated on chain, but I think it's not.
We're doing an ENS lookup on this, and
like it should be able to grab what's existing. I think you can't create new ones.
Yeah, I can't look this up.
Okay. So both equally annoying projects that we have to tackle. But other than that, we are feature complete.
Yeah.
So we can stop this recording. This has been an implementation of an RPL refund scenario. Next steps, we need to get this RPL from Holesky from the Rocket Pool team. I'll coordinate with Schifrin, get a POAP and a forum post going. And we need to do another session of recording just explicit use cases. And I should probably start writing down some more documentation about what it is, what it's supposed to do. I think that's next steps.
That makes sense. Yeah. Yeah, testing this is going to be interesting because this is definitely there's a lot to test here.
Yeah. But and then in production, yeah, let's get there.
Yes. Ability to set the RPL.
Ooh.
What branch am I in? Oh, I'm on my. push into that. All right, cool. That's pushed up there, and I will make a PR into Ramana's repo. And I'm going to go ahead and stop the recording. Curious how long that took.